Okay, good morning again. And today we are going to, I am going to deliver our third lecture on metal forming processes. In fact, it is not third; it is fourth lecture. Okay. So up to now we have covered in metal forming processes introduction, classification, then material behavior in metal forming, then tensile test and important engineering properties, role of ductility, then material properties in metal forming. Up to this we have covered. Okay, just a second. Okay, so up to flow stress and average flow stress we have covered till now, and today we are going to start new topic, that is the effect of temperature in metal forming processes. Okay, so in the previous class, perhaps I have told that temperature plays an important role on the material properties. In material properties, basically the ductility and your strength coefficient. Okay, so in this equation you can see your flow curve is sigma equal to k in sigma equal to k into epsilon raised to the power n. Okay, so k is your strength coefficient, which depends upon your material. N is your strain hardening exponent or work hardening exponent, and sigma is your flow stress. Okay, so flow stress is the stress which is responsible for the plastic deformation of your material. Okay, so let us come to directly to the effect of temperature, how this temperature is affecting your material properties in metal forming. Okay, or how it is useful or it is not useful in the case of metal forming processes. So for any metal, K and A, that is the strength coefficient and your work hardening component in the flow curve depends upon the temperature. Both the strength K and your strain hardening exponent is reduced. Okay, at higher temperature. Okay, so what does it mean if your K is getting reduced because your flow curve was, let me not come again and again to that particular slide. Let me write here. Okay, this is our flow curve, and we are saying that with the increase in the temperature, your strength coefficient is decreasing. Okay, it is getting reduced, as well as your strain hardening exponent is also getting reduced. Okay, so with the increase in temperature, what we can see? We can see reduction in K, as well we can see reduction in your work hardening exponent. So what will happen if you are increasing temperature? Your flow stress will ultimately decrease. Okay, so with the temperature, you could see the flow stress curve. Between the flow stress and the temperature, you can see your flow stress is decreasing. Okay, so this is how you can understand your effect of temperature on flow stress. Then yes, so depending upon the temperature range, I think this you might have studied in your manufacturing course also. There are three temperature ranges that whether your material is getting deformed at room temperature, then it may be called as cold forming. Then there is another type of or another temperature range, which is hot working. In hot working, we are taking consideration of your recrystallization temperature. Okay, so I hope you are aware about recrystallization temperature. Then there is another type of or temperature range which is not neither cold or neither hot, but it is in between. So it is called as warm working. So it is slightly above your cold working and less than the hot working temperature. Okay, so let us see how these are differentiated from each other. What are the advantages of these temperature ranges, that is hot working, warm working, and cold working. Let me move ahead. First, we will take cold working. So as the name indicate, the cold working is performed at room temperature or slightly above your room temperature. Many cold forming processes are important mass production operations. Many forging operations or many sheet metal working operation. You can see those are the mass production operation. They are carried out at room temperature or slightly above room temperature. So all these processes like blanking, punching, and sometimes in wire drawing also, these are the processes which are conducted at room temperature or near to room temperature. That's why these processes are called your cold working processes. And all these processes, you will notice that all these processes are mass production processes. Okay. There is one more feature of cold working processes. There is in the case of cold working processes, the minimum or usually you can say no machining is required. Okay, so why this no machining is required? Why this minimum deviation from your actual size is there? Because all these operations which are done at room temperature, all these operations are near net safe or net safe process. Okay, so either we are performing net safe processes. Net safe means the safe which is exactly desired in the process. Okay, so we are either these processes are net safe processes or near to net safe process. Okay, if it is near to net safe process, then you may require for some further machining, but uh, it is not that much. Okay, it is very less amount of material removal is needed in the case of cold working processes. Okay, so here are some listed advantages which I have listed out. I have because you might have studied these topic, that is cold working, warm working, and hot working as a part of your manufacturing processes. So I will quickly cover the advantages and then disadvantages of all these three types of metal forming ranges or the temperature ranges. Okay, so the first and foremost advantage of cold working is it has better accuracy. Why it is having better accuracy? Because these processes, as I have told, these are the net safe processes or near to net safe processes. Okay, so since we are having better accuracy, the process is near net safe process. We obtain closure tolerance. Okay, we are able to obtain closure tolerance. Also, another advantages because of this in the cold working region, that is the we obtain better surface finish. Okay, so since there is no heating, so there is no surface irregularity due to rise of temperature and or the reaction with the your forming environment. Okay, so we obtain a very good surface finish, or we can say very good better surface finish as compared to warm or hot working processes in the case of cold working. Yeah, it is obvious. No eating of work is required. Then strain hardening increases strength, and when we are deforming your metal at room temperature, your strain hardening increases your strength and hardness uh, of your final product, and which may be desired, or you can say it is desirable at most of the time, that that your strength or strength as well as hardness of your material should get improved. Okay. Then next advantage, grain flow during deformation can cause desirable directional properties. So you can say it is again the improvement in the mechanical properties of your final product. Then besides the advantages, there are disadvantages also. Okay, so there are few disadvantages of cold working process. So in the case of cold working process, because we are conducting the final operation at room temperature, so obviously there is a higher requirement of forces as well as power. Okay, so if we compare these processes with hot working process, the force requirement may be quite less as compared to your cold working process. But in the cold working process, the force and power requirement is very high. Another disadvantage is that if there is any surface irregularity in your initial ingot, or your initial metal piece, then it may it may distort your final product. Okay, so as for cold working, your starting workpiece must be free from any kind of surface irregularity like scale, or there is any dirt or any other type of surface irregularity. So your final product should be free from uh, any type of surface irregularity. Then next disadvantage in the case of cold working is your ductility and straight hardening limit the amount of forming that can be done. Okay, so when we are forming your component at cold working, we are saying that your strain hardening is your strain hardening is increasing the strength and hardness of your final product. Okay, so what we have to understand, that there is a limit. If this is also causing a limitation on the forming, if your material is getting strain hardened before it reaches your final desirable shape, so you will require the larger forming forces, or sometimes the material becomes so hard that it is not deformable further. Okay, or the force requirement becomes very high. So sometimes this strain hardening phenomena is desirable. Sometimes it is not desirable, depending upon the situation and material property. So if you want to overcome out of this problem, that is if the material has been get hardened, or the has strength of your product has been increased, how you can get relief from it, how you can reduce the force requirement in the case of cold working. So in some cases, what you have to do, you need to anneal. Okay, you need to heat your heat your semi-finished product, then allow further uh, uh, get it uh, temperature get reduced, and your when it comes in at your room temperature, the your semi-finished product get annealed. Okay, and which may allow you for further deformation with the less power requirement or force requirement. In some cases, your ductility of your material is not sufficient that you cannot deform, or you cannot plastically deform metals into desired shape at room temperature. So in those cases, you for those materials you cannot deform material plastically at room. Okay. Then next type of warm working process, or next type of metal forming process, is your warm working depending upon your temperature range. Okay, so in warm working, what we are doing, basically we are performing your forming operation above your room temperature. It is sufficiently above your room temperature, but it is below the recrystallization temperature of your uh, material. Okay, so the dividing line between your cold working and warm working is often expressed in terms of your melting point. So Tm is your melting point. So which temperature range may be called as your warm working, we may depict using this uh, equation. That is, if your uh, um, temperature of your metal block is less than, or you can say greater than 0.3 times of your melting temperature, then it is not cold working. And if your working temperature is half of your melting temperature, then this temperature range may be termed as your warm working region, or warm working process. So what are the advantages? So this is the obvious advantages. Since we have increased the temperature, so since we have increased the temperature, what has happened? Your strength is reduced, your work hardening exponent is reduced. So obviously your flow stress is reduced, and if your flow stress is reduced, it means your power requirement and as well as your force requirement is reduced. Okay, so this is the obvious phenomena in the case of your warm working processes. Second advantages is more intricate work geometries are possible. In the case of cold working, you may not be possible to get near process in the case of intricate work geometries or the complex geometries. Okay, so in the case of in the case of warm working process, the more complex geometries can be obtained using your warm working process. Then because in the previous process, when your material get hardened due to strain hardening, what we need to do, we need to do anneal, or we have to anneal your semi-finished product, and then further we have to carry out your forming operation, or metal forming operation. But in the case of warm working process, since the material is not getting strain hardened because it is already in the warm condition, so the need of annealing is reduced, or sometimes you can say it is almost eliminated. In warm working process, one more advantage is there, that is there is low spring back. I have not listed as a disadvantages in the cold working processes. In the cold working processes, the spring back is there is a considerable spring back issue. But in the case of your warm working processes, this spring back is reduced, or the spring back becomes low. Then let us move to the next temperature range, that is the hot working. Okay, so in hot working, as the name indicate, it is carried out at
Sir.
yes.
Sir, what is spring back?
Okay, a spring back is that when you deform any metal block. Suppose let me take draw one example here. So suppose uh, okay, just a second. Okay, so suppose this is your final your first initial your initial metal block, or you can say you are having a rod, initial metal block in the form of rod, and you want to obtain components of the final product, something like this. Suppose you are performing bending operation. So if you are conducting it at a room temperature, what will happen? You might you may visualize it using your scale. If you are having your scale, you can bend it, and what will happen if you release your force? It will come in its original position again. Okay, and if your force is sufficient, then your scale may bend like this. Okay, or you any metal bar, if you are having, it may bend like this. Okay, so what will happen? Suppose after the application of force, your material is in this form, in this particular state, and if you release your force, there will be some kind of deflection. Okay, your material will will not be in the position in the same position where it was in the case of during the application of force. So what will happen? It will go back by a some extent. Okay, so initially fine, uh, your rod was like this. If you applied force, then it became like this, it got bended, and the in during the bending, when you remove the force, it tries to get its original position, or some there is some kind of elastic deformation exists. Okay, so due to this, your spring back phenomena comes into picture. Okay, so if you release force, there is deviation from your final product to the desired product. Okay, so this deviation is called as your spring back. Okay, so this deviation is maybe called as spring back. So it is in different form for different type of metal forming processes. Uh, and in the case of because these processes are being carried out at if these processes are being carried out at room temperature, then this spring back phenomena is more as compared to if we are the processes which are being conducted at higher temperature. Okay, so in the case of warm working as well as hot working, the spring back is low, but in the case of cold working process, the spring back is high. Okay, I hope it is clear.
Yes, sir.
So hot working processes, uh, as the name indicates, hot working processes are carried out at above room temperature, and normally this recrystallization temperature for most of the metal is about 1/2 of your melting point. Okay, so you can say it is 0.5 times of your melting temperature. That's why we have taken the temperature range that all the processes which are having temperature or which or the processes which are being carried out below half of your melting temperature, these are termed as your warm working, but obviously being carried out at above 0.3 times of your melting point. So that is why this is the temperature range which is chosen as your warm working region or warm working range. Okay, so yeah, so recrystallization temperature is one of your melting point on absolute scale, that is in degree Kelvin. In practice, the hot working are usually performed somewhat above your 0.5 of your melting point. So it is slightly above your recrystallization temperature. And as we know that due to increase in temperature, your what happens, your material become soften. Okay, so due to increase in temperature, your material becomes soften, and you are able to easily deform your metal block. Okay, so in the case of hot working processes, the force requirement and power requirement are lower as compared to your warm working processes or working processes. Okay, so why we go for hot working processes? So there is a capability of substantial plastic deformation of metal far more than possible with cold working or warm working, because since we have increased the temperature, the power requirement has get reduced. Why this power requirement is reduced, this I think we are already aware in the discussion taken place till now, that your strength coefficient is getting reduced. Okay, or strength coefficient is very less as compared to the strength coefficient at room temperature. Okay, so strength coefficient at high temperature is substantially less as compared to the strength coefficient at room temperature. The strain hardening exponent is very less, or theoretically you can say it is near to zero. Okay, in the case of hot working processes, and due to reduction in strength coefficient and strain hardening exponent, your ductility of your material or the pieces significantly improve. Okay, so if your ductility is improved, it means you can flatten your material or the metal into a desired shape. Okay, moving to the advantages. What are the advantages of hot working processes? So from the discussion till now, you might be aware, you might imagine that the hot working carries a lot of advantages. So in the case of hot working processes, the first advantages is you can say the work part shape can be significantly altered. Second advantages is already well explained, lower force requirement and power requirement. Next advantages, metals that usually fracture in cold working. So this was the disadvantages in the case of cold working, that the material which are not ductile enough and whose material properties do not allow for plastic deformation at room temperature, they can be easily deformed in the case of hot work. Okay, so the material which usually fracture, it means the material which are brittle at room temperature, maybe maybe more ductile when they are being hot formed. Okay, then next advantage is no strengthening of part occurs from work hardening. Okay, so why this no strengthening is taking place? Because your strain hardening exponent is near to zero at room temp at your higher temperature. Okay, So that is why this strengthening or increment in brittleness of your metal block getting reduced. Advantages in cases when part is to be subsequently processed by cold working. So okay, so let us now move to the some disadvantages which I have listed out. After that, we will move to the next. Okay, so the disadvantages of hot working processes are the dimensional accuracy. It is obvious because when we are conducting uh, any deformation at higher temperature, it will get solidify, and the overall size there may be variation from your from the desired in the final shape. There may be some variation from your desired shape. Okay, total energy requirement is very high. Why this total energy requirement is high? We could reduce in terms of in terms of force and power requirement. But if we see the overall energy, that is including the thermal energy that is needed to heat your workpiece, your overall total energy requirement becomes very high. And due to the increase in temperature, there may be issues. This is a further disadvantages of your hot working process. There may be surface issues also. Your work surface may get oxidized, and there may be poor surface finish, which may lead to shorter tool life. It is also affecting your tool life also.